All right, everybody, welcome to covalent naming and acid naming. That's kind of weird. Covalent and acid naming is probably what it should be called. We're going to be learning about naming covalent compounds and acids. So any covalent compound is going to be a metal and another non-metal, at least one metal and another non-metal. So we're talking about, when we say covalent, it means it's molecularly bound, all non-metals. To give you an idea of what non-metals are, looking at the periodic table, it's anything above and to the right of the stair stepper we're going to be talking about is non-metal. So all these things over here. And even though all these things over here have labeled charges when we're talking about ionic compounds and covalent compounds, we don't worry about charges unless we talk about acids. So charges don't matter when you have two or more nonmetals unless you're talking about an acid, and we'll get to that here in a second. Let's go ahead and start with the simple covalent things, binary compounds, which are two nonmetals from the periodic table. We have to use these prefixes, which you should already have memorized: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. And it comes pretty straightforward. You generally put the prefix before the name of the element, and you end with "ide." So let's go ahead and start with this first one. This is N2O5. I would call that di-nitrogen because there's two nitrogens. Di-nitrogen pentoxide. Now you could write penta-oxide, but because there's two vowels and it'd be penta-oxide, they just combine it into one. So di-nitrogen pentoxide would be N2O5. All right, the next one, NO2. Now you'd want to call this mono dioxide, or mononitrogen dioxide, excuse me, but we don't use the word mono or the prefix mono when it starts with that element. So this should just be nitrogen dioxide. No mono, as I tell you in class, chemists hate mono as much as everyone else does. So there's no mono, it's just nitrogen dioxide. And to bring that point home, CO would be carbon, but we can finish it with a mono, carbon monoxide, carbon monoxide. And that's a lot of the binary compound naming. So anytime we have two or more nonmetals, that's pretty much the way that we name it. Now, when we get into acid naming, that's two or more nonmetals, but we have to pay attention to charges because acids break apart into charged things in water, into ions. They break apart into ions and water. So there's two different kinds of acids. The first one is binary. So again, there's two acids. The first one is called binary. It's pretty straightforward. It's hydroxylic acid. So whatever the bl thing that hydrogen is attached to is going to be what you write. Again, acid, we're going to be looking for things that start with H and are aqueous. So it has to start with an H and it'd be aqueous. For all of these, we're going to assume they're aqueous because we're talking about acids and it just gets in the way. So for this first one, name HF. The first thing you should notice, hey, it starts with an H. That means it's probably going to be an acid. The next thing you should look at is it just made up of two things from the periodic table? For me, it looks like it is. There's an H and there's an F. Hey, two things. Therefore, we're going to name it hydroxylic acid. The bl is going to be fluor. Hydrofluoric acid, and that's the name of HF. Now if we go backwards, it says draw hydrochloric acid. Again, hydroic acid tells you it's two things. So mainly the hydro part is actually what tells you that it's just two things from the periodic table. So if this is two things from the periodic table, it's an acid, so that tells you one of them is going to be H, and chlor tells you the other one's going to be Cl. Now your question is, what about charges? Because we do have to look at charges because again, these things break down in water into charged species. So hydrogen has a +1 charge from the periodic table, and chloride has -1 charge from the periodic table. You only need one of each. And HCl, we could put aqueous if we want to, would be your answer for hydrochloric acid. Hydrosulfuric acid, very simple. Common mistake though is people just put HS. We know we're dealing with a binary acid, meaning just two things from the periodic table because it says hydro. We know we're dealing with an acid because it has an H out front, so hydro something acid is going to give us an H out front. We know hydrogen has a +1 charge, sulfur has a 2- charge from the periodic table. If you didn't know that, watch the ionic compound naming or look at the periodic table. Here we have S is a 2-, H is a +1. We need 2 hydrogens and 1 sulfur to make H2S, which would be hydrosulfuric acid. All right, so that's binary acid naming. It tends to be very simple. In fact, all acid naming is simple if you let it be. Now let's go ahead and move on to oxyacids. So oxyacids are things which have oxygen, and the oxygen comes from polyatomic ions. If you don't know polyatomic ions, make sure you watch the polyatomic ion video prior to watching this one. All right, so there are 2 cases with oxyacids. It's either going to end with an ic acid or an us acid, but one thing's for sure, there is no hydro in any of these cases. It's just going to end with an ic acid or an us acid. If it ends with an ic acid, it tells you that the polyatomic ion contained an 8. If it ends with an us acid, it tells you the polyatomic ion contained an 8. I like to say in class, if you ate the ic, you got the itis. So if you ate the ic, you got the itis. In other words, 8 becomes ic, and ite will become us. Let's talk about what that means. Again, we're assuming all of these are aqueous, but the first thing you should notice about this is it starts with an H, and it's got an oxygen in it. Starts with an H, dude's gonna end with acid, no matter what. Next thing you should pay attention to is it's got a polyatomic ion, because it has oxygen. This polyatomic ion you should recognize as carbonate. Again, if you ate the ic, in other words, if it ends with 8, we're going to change it to an ic acid. This is going to become carbonic acid. Let me rewrite this a little prettier. This is the acid that forms when you have a carbonated beverage that you drink. Yummy. All right, this next one, nitric acid. Let's go backwards. Nitric, ic had to have originally been 8. Again, if you ate the ic, if it has a polyatomic that ends in 8, we're going to change it to an ic acid. Therefore, if we have a nitric acid, that means it originally had to come from a nitrate. Nitrate is NO3-. To make it an acid, we have to add H+. We need one of each. And NO3, we can make it aqueous to put a stamp on it, is nitric acid. Nitrous acid, ooh. If it's an us acid, that means it originally came from an ite. So nitrous acid originally came from nitrite. Nitrite is NO2-, one less oxygen than nitrate. We have to add an H+. You just need one of each. HNO2 aqueous is nitrous acid. Let's go ahead and name this one H3PO4. We should recognize the PO4 as phosphate. So PO4 3- is phosphate. The H3 is telling you, hey, it starts with H. It's got to be some kind of acid. We don't use hydro because there's oxygen in it. So we've got some kind of phosphate acid. Again, if you ate the ic, this had to have originally been ic. That doesn't sound very good, phosphoric acid, and I would never put this on a test, but your next best answer would be phosphoric acid. It just sounds prettier. So phosphoric acid is H3PO4. Last but not least, phosphorus acid. Well, if it's phosphorus, it had to have been from an ite. Phosphite is PO3, 3-. Again, one less oxygen than phosphate. And we know that H+ has to come because we're talking about an acid. Again, you have to look at charges. We need 3 H+s to cancel out the PO4, 3-. And therefore, PO3, 3-. H3, PO3. So 1 PO3, 3 H+s will give me H3, PO3, and that is phosphorus acid.